the girls will naturally accumulate on the dance floor all by themselves, okay? Thus, at a steady state, the number of girls on the dance floor will roughly be steady, okay? Until you start, and once the girls enter the dance floor, the men will start to gravitate towards the dance floor, right? So, the number of girls will stay roughly constant, because they're the number that would naturally be there if there are no boys at all at the party. Okay. So here we could label this point as.
You're gonna have a YouTube moment watch.
As we'll call it like the
Berkeley
the characteristic density.
Okay.
Okay.
We should title it Berkeley Party.
We'll call it rho prime divided by 2. Or rho prime divided by 2.
What does the B stand
You're gonna
for?
have to give an expression for that.
Yeah, you have to define the terms on the side.
Before I believe that this is constant.
Characteristic density. Density of breasts.
I thought I was supposed to be doing homework.
Okay. Yeah. So, when there are no men at all at the party, you'll have this characteristic density on the dance floor, right?
You won't have any
Because
women
girls-
at the party. There are no men.
That's not true. If you have a...
Okay,
you-
you're gonna have a
if you-
few. You're gonna have a.
Yeah, okay. So, if, hypothetically, in our idealized system, okay, at steady state, we have a set density of females on the dance floor, okay?
These are pretty good pictures.
As the concentration of men on the dance floor increases, the women roughly stay on the dance floor in the same proportion until we reach this critical density. We'll call this rho D star.
I like autofocus more.
This is critical
Oh.
Yeah.
density. Dicks. Oh, yeah.
No, Joey. Your functional expression for rho prime has rho D in it.
That's not true. And rho D is like a function of geometry, right? I mean, you could figure it out analytically if you want. Actually, not analytically, but you could do various algorithms. Monte Carlo simulations, break the dance floor into n squares. Okay. We'll distribute n sub b divided by 2, randomly. This may or may not be good. You might have to do like some sort of correction because they might want to.
They will converge in the middle.
Yeah, they might want to be closer to each other. So I mean,
Girls always dance.
that's easy to fix, right? You seed it randomly, and you have like a Boltzmann factor where the energy for spots far away from other females is less likely than spots nearby. So I mean that's relatively easy to do. That's well explored in statistics.
And there's multiplicity involved in that.
And then you start randomly distributing the men, but they're gonna surround the females, right? That's a natural tendency.
So this is what we get
So,
for those.
actually, they'll probably want to optimize their position such that they're touching as many females as possible. And once the average female starts to see men on more than 2 or 3 sides, or it's probably like something like 2.5 sides, right? That's when you reach this critical density, and that's when the concentration of females is going to drop rapidly.
So rho. Okay, so you can define rho prime B
There's another term for
as a function of rho D star.
that I don't have.
You can put that down right now.
I could rho
Rho prime
prime B. No, that's not true.
What are the
Ro-
X's and O's?
males and females.
These are these are females. These are males. So I mean, yeah.
No,
like I said,
not rho prime B. Just rho B. Rho B over 2.
rho B over 2.
Yeah, and rho D asterisk.
Yeah,
Asterisk.
yeah, sounds really true. I mean, and there's lots of functions that we could, like, this looks a lot like lots of expansions. So you could expand this region, actually. What's that word? I forget. But yeah, you can perform all sorts of algorithms on this. These are relatively, this sort of distribution is well explored because this looks like the profile of a nuclear density profile of a nucleus, right?
Yeah.
So you have a thin skin. I think it's like
Yeah.
lemon.
So right now you're on
Lemon
full
something.
manual. Okay.